All right, we are going to go over our exponential functions, looking at growth and decay. So take a second to make sure you're on the right worksheet. This should say exponential functions, graphic organizer, okay? So we're gonna look at the ways we will see this as an equation, as a graph, and as a table. So first we're gonna look at the equations. We know that the exponential function has the equation y equals a times b to the x power. So our exponential, right? I like to write it sometimes with this x up here because what it's saying is that my x is going to be in the exponent place. So as we see here, the x is in the exponent place, and we just have two numbers, an a and a b value. So for this first example, our a value, right, is going to be that first number, and our b value is going to be the second number, and the x will be our input. So our a value is 4, and our b value is 2 over 3. When we're thinking about this equation, this b value is going to tell us whether it's going to be a growing equation or a decaying equation, meaning it's getting smaller. So 2/3 is, if you think about it like a decimal, is less than 1. Well, anytime my b value is less than 1, I am looking at a decay, right? When it is less than 1, it is going down. My graph will look something like this. And when I'm talking about the equation on the right side, we're going to see the a value, that's my starting number, is 0.5, but my b value is 5 over 2. Now 5 over 2 is a fraction, but it is a fraction that is equal to 2.5. So that means that my fraction number, right, is actually a number greater than 1. And so I know my equation is going to be growing. Okay, so when my a is less than 1, I know it's going down. It's a decay. And when my a is greater than 1, I know it is a growth and it's going up. All right, let's look at some graphs. So same sort of thing here, except for we're going to be looking at the a value and the b value and trying to write the equation. So the a value is the y-intercept. It's the starting value. So I can see in my first graph, the y-intercept here is just 1. That's easy to find. And in order to figure out the b value, I just need another point. I need to find how much I am going up. We can see that this graph is growing. It's a growth. But I need to make an x and y table to talk about how it's changing. My first point is at 1, and my second point is at 0, 1, and my second point is at 1, 3. So if I think about that as a table of values, I can think about what's happening to change from a 1 to a 3. Well, as I change, right, from a 3, as I change from a 3 to a 1, right, what is happening? The y value is changing by 3, right? This is my second y value. And my first y value was 1. So when I divide those, I end up getting 3. Or as you can see when you look at the table, this is a multiplying equation. So I am multiplying 1 times 3 gives me 3. And if I went to the next one, I would probably find that this goes to 9, right? So if I multiply again times 3, I would get 9. So my equation should be starting with 1 and then multiplying by 3 again and again and again. X is just the number of times I'm going to multiply. We might also see this equation without the 1 because I don't really need the 1. I could just write it as 3 to the x power. Let's do another one. We can see that this graph is a decay. It's going down from left to right, but we're going to figure out what the numbers are. So when I go down this way, if I start from my y-intercept in this one, my y-intercept is 2. And I'm going to look for the next value. So 0, 2 is one of my numbers, and the next point would be 1, 1. Well, that point at 1, 1, if I think about what's happening here, if I go from 2 to 1, how did I move? Well, I moved down by dividing my number in half. But let's also do it mathematically. So what I did here is I divided 2 in half, right? Or I multiplied by 1/2. So here, if I think about that, my y2 divided by my y1, my y2 is this number, 1 divided by my first y value, which is 2, I get 1/2 or 0.5. You can write it in either way. I'm going to use the fraction. So my equation should be my a value multiplied by my multiplier, right, which is 1/2 to the x power. And again, that x is always going to be in the exponent place. What this says is I'm starting at 2, and then I'm taking half of that again and again and again. However many times I do that, I'm going to be cutting it in half each time, which is why it is going down. For the tables, you're doing the same thing. You're just looking for the a value. And just like when we did linear equations, the y-intercept, right? The y-intercept is where x is 0. So we're looking for our 0 on our x, and our y-intercept is 12. And then I'm trying to see what's happening here, right? As I go down, what am I doing? If I look at this, I might be able to see that I'm dividing by 4, right? 12 divided by 4 is 3. 3 divided by 4 is 3/4. But sometimes that's hard to do. So what we need to do is take our y2 and divide by our y1. So our y2 is 3 and our y1 is 12. And when we divide that in our calculator, we're going to get 1/4. Well, 1/4 is like dividing our number in 4 pieces, right? 1/4. So the equation is I'm starting at 12. I'm taking 12 and I'm dividing it into 4 or multiplying by 1/4. And then I'm doing that again and again and again, which is why I do the multiplying again and again with the exponent. Same thing over here. Where am I starting? My starting value is where 0 is on my table. So my a value, my initial value is y is 6. And as I look here, I can tell I'm going up. I'm growing. Okay, so we know this is a growth. It's going up. But how much is it going up by? Well, you might know that 6 times 5 gives you 30. But let's do it the math way. So y2 divided by y1. Well, here's y2, that's my 30, and here's y1. So let's take 30 and divide by 6, and that should give you 5. So my b value and my a value just get plugged back into my equation. So my a value goes first, that's where I'm starting. My b value is the multiplier, and the x is the exponent. Y equals 6 times 5 to the x power. All right. Now, couple problems at the bottom are going to be word problems, and you're just really matching here. This is kind of an easy intro to the word problems. So the A is always going to be the initial or the starting number, the starting value. And then the B is going to be how much I'm growing or decaying by. Growing is going up, decaying is going down. So let's look at the first one. Patricia's car has a starting value of 20,000. Starting value, that's my A. And depreciates. Depreciates means goes down at a rate of 33% each year. So I know I'm going to be going down 33%. Well, let's think about when we talk about percents, we're talking about starting at 100 and going down 33. So 100 minus 33 should give me 67%. But I don't want to put a percent in the equation. I want to write that in its decimal form. And so 67% as a decimal is 0.67, right? Think about 67 cents on the dollar. So this is my B value. And I can see right here an equation that has an A of 20,000 and a B of 0.67 is answer D. You'll notice all of these have the same A value, which makes them a little bit, we're focusing really on the B values here, okay? So the second story says there were 20,000 cases of the flu, right? People are sick with the flu, and they were reported in January. It is expected that each month there will be a third of the cases as the previous month. So they're expecting our flu to go down by 1/3, right? A third is going to be how much I'm going down. That's going to be my decreasing rate. 20,000 is where I'm starting from. And so I'm looking for one that has 20,000 in the A value, right? Which all of these do, but then talks about going by a third, which is this one, 1/3. So this 1/3 is that fraction right there. And so we can tell that B, right, is our second one. Jenny made a $20,000 investment that is doing incredibly well. It is expected to triple each year. Oh my gosh, triple. Okay, so we're starting with 20,000 again, and we're tripling. Triple means multiplying by 3, right? We are getting 3 times bigger. That's a crazy good investment. I don't think that really exists. If we look at our options here, right, we see that 20,000 with a 3 as the multiplier, right? The 3 is the multiplier. So I know that this is my B value, and A should be the correct answer. Last one. Obviously, we know it's C, but let's talk about why. Ronnie bought a highly sought after vintage car for $20,000. When you buy something, that's the starting value. The value of the car increases, it's going up at a rate of 33% each year. Again, anytime I'm working with percents, I'm thinking about 100 plus that 33, if it's increasing, would give me 133. But that is a percent. And I don't want to put the percent in the equation. I want to put the decimal version of that. So if I take that and I divide it by 100, I'm going to get 1.33. Which means I can see this here, right? This is my percent. I'm increasing by 1.33 every time. And again, that car is getting more expensive. That's because it is a rare car, right? Most cars go down in value, but old cars sometimes become more valuable. So there you have a couple examples of the word problems. In your practice today, you're going to see some word problems, but you're also going to be working on the tables, right? We worked on the graphs last time a lot, so we're going to really work on those tables today and writing the equations that you see. So head on over to your practice and get started, and let me know if you have any questions.